Hello, another episode about hurting electrons. In any solar system, you always have excess capacity. You have to design for those worst days, which are only about 10% of the time. And so those systems are always have power that you're losing. I suggest you heat water with that. This is ideal for a camp situation. Right here we have a 3525 inverter board that you can buy on eBay. This is the surface mount type. It's a little harder to work with, and I use a TL431 to invert the signal, because a normal inverter board goes up to a certain voltage and shuts off. In a dump load, what happens is you want to have the maximum output until you drop below a certain voltage. So here's the inverter board. Right here you have a little power supply to run it, to give it to 12 volts. If you have an external source that can supply that, then that's all you need. Here we have the heat sink with 2 FETs on it. This drives 2 FETs 50% of the time, so you have to have 2 of them in parallel to get 100% output. Right here I have a little switch to demonstrate what the difference is between having a panel operate at power point or just direct connect, as a lot of people do. So right here we have the power. See, we're at almost 63 volts. If I do a direct connect, it goes down to 31 volts. About the same current, because solar panels are current sources. But you see you've lost half your power by not using PowerPoint, and that adds up, because most of the day you're not getting full sun. Anyone can heat up water those 2 hours of the day when the sun is directly on the panels. But other than that, you're wasting a lot of your power. So this is basically the setup I have. In another video I have a 3525 board which is discrete. It's easier to modify. You don't need to add the TL431 inverter circuit. What this does is it samples the voltage. It looks for a reference of around 2.5 volts. When it's over that, the inverter turns on because it drags this pin down. There's a power supply, a fan if you need it. If you have enough FETs in parallel, you won't need that at all. And here's the water heater. Now this is coming out. It will be pulsed, but it can be pure DC. So this was what I'm designing this for someone. They have a high voltage DC relay that can take 300 volts. So that's their control system. You can see in the instructions later that if you connect up pins 5 and 6 to a thermostat, you can turn the inverter on and off. Here's the basic schematic of the inverter. Most of it you just kind of ignore. What we have to do is remove R11. This op amp is there just to, when it gets to overcurrent in a normal inverter, it latches off. You've probably seen this a lot of times. You have an inverter, you overload it, the beeper goes off, and you have to remove power and then turn it back on in order to get it to work. If we're turning it on and off with temperature, we have to disable that. The other thing is we have to add this little capacitor to slow down the frequency. There's no reason to switch at really high frequencies, and that just causes extra heating of the FET. Something you can mount on the back of the board. It's C2, and it's the side of C2 that's closer to the integrated circuit. So the modifications are there that you follow. Again, this is the circuit. Fairly simple. But again, I would use the through-hole component board if you were going to build this, unless you had this board around. maybe you have some other use, but this is a little harder to modify. Again, this is my setup here. I have a grid tie inverter, which is 12 volt. It's running off 60 volt panels, and so I have these two buck converters in parallel to turn the voltage down. There's a voltage sense here, so that when the voltage drops, it throttles down the inverter. It's a nice little system. This PowerPoint heating system could be attached to any charge control that you have. So basically, once your batteries get near fully charged, they'll be drawing less current from the panels, and now you can send that excess current over to your water heater. I have a camp, and I have around 1,000 watts of panels for water heating, but that also runs the whole camp, refrigerator, other things. I even have a dishwasher with heated dry, so you don't have to operate with a lot of batteries. I always think that you should have basically more solar panels than batteries. The solar panels will last a lot longer. They'll get you through those hard times. Batteries are just going to go bad after a few years. So the heating element I have right now, it's a 3500 watt, and that figures out to be about 16.5 ohms. So I can only get about 225 watts into this heater before it maxes out. And I have 560 watts of power, so I can run about 250 watts into the grid tie. That's all I really want to put in there, and the rest of the panel power I put into water heating. It's a neat little system. It transitions back and forth. Hope you found this interesting. Thanks for watching.